The next part is to figure out what's going on with M double prime. That's a discussion about concavity. Concavity is this feature of a graph. As I explained it the other day, we have the idea of concave up and concave down. So this is a situation where everything is concave up. Basically, if it's like a U, it talks about the way in which the graph kind of curves. So graphs can kind of be concave up, or they could also be concave down. Some of the tricks we talked about in class was that if it's like a U, that's concave up. If it's like a lowercase n, that's concave down. I do want to point out, down. See? It's like a lowercase n. Isn't that clever? I'll point out that it's totally possible to have a function that is increasing and concave up. It could also be increasing and concave down. We could have a function that is decreasing and concave up, or decreasing and concave down. So it really is a very different feature of the graph, and it has to do again with the way the graph is curved, up or down. So as I look at this function, as I kind of trace it with my eyes, I can see whoever drew this function, which of course was obviously me, thought -1 was an interesting point. And -1 would be labeled as a point because at that place it seems like the function changes from decreasing one way to decreasing another way. Decreasing more and more and more and more to decreasing less and less and less and less. There's a change in concavity when x equals -1. That means there's a change in sign with the second derivative. So that's a place where I'd want to, on my second derivative number line, that's a point of interest when x is -1. For all of this first area here, for this entire region, it's all curved in that concave down fashion. That all could be part of a lowercase n. So there's nothing happening before -1, but at -1, there's that little switch happening. That's all concave up. It looks like at 4, there's another switch in concavity. It's kind of like this, the purple stuff is clearly like kind of like a lowercase u, but that red part is more like a lowercase n. So something changes at 4 as well. And now it's just a matter of like, now that we've recognized what's going on with the concavity here, let me try and use some of the same colors so that's really obvious. So for all the red portions, that graph is concave down, and for the purple portion, it's concave up. Those changes happen when x is -1 and when x equals 4. Those are considered points of inflection. So now it's just a matter of marking the signs, really. So basically, for that red region, all this stuff, concave down means the second derivative is negative. In that middle portion, as x goes from -1 to +4, where I have this lowercase u, the second derivative will be positive, because that's all concave up. And the red portion from x onward is negative, that's concave down. So that hopefully gives you a better idea of what we mean by concavity, how we can use the second derivative to determine concavity, and also what a point of inflection is. Anytime we have a change in concavity, that's considered a point of inflection. In the next video, I'm going to define and talk about non-differentiability, which is a brand new term, so you'll probably be watching that video for sure.